higher order differential equations, and if the right hand side is equal to 0, we can call this homogeneous. This is the fifth derivative of y plus 2 times the third derivative of y plus y prime. Step 1 is we write the characteristic equation. I don't know why I'm writing that font. So we would say m to the fifth plus 2. So what I'm doing right now is I'm just replacing the order of the derivatives in a polynomial, right? So I'm not saying that this is the fifth derivative of m. I'm just saying there's 5 m's. This is m times m times m times m to get the point. So I'm just replacing this as a polynomial equation. Now, a derivative of order 1 is just one polynomial. It's a polynomial of degree 1. Okay. So now we want to find the roots of this that make this true. So we can see that if we write here, if we factor out a m, you could have m to the power 4 plus 2m to the power squared to the power squared. That makes, it's kind of a weird way to say it. Plus 1 is equal to 0. And, well, you could definitely see that m is equal to 0. So that's one of our roots. And if we have an order 5 derivative, and then we'll have a degree 5 polynomial, and if we have a degree 5 polynomial, we should have 5 roots. So we need to find 5 values of m that make this equal to 0, right? That's the goal. Okay, well, we got rid of this first one, so let's just focus now on m to the power 4 plus 2m squared plus 1. Well, I would say, what I would argue here is I would say, what is a expression times another expression that would equal this? And I see a 2 here and I see a 1. So what I do is I kind of just usually jot something down and I check it. So maybe m squared plus 1 squared would be it. So the same thing times itself. And real quick, we could just verify this. So m squared times m, well, I'll write it out. I'm not going to be lazy. M squared plus 1, m squared plus 1. We would see that that is m fourth plus m squared plus 1. And yes, this is the same thing that we had earlier. So that is that. Okay. Well, I'm going to erase this just to save some space for later, because these can get kind of large. We might do another example. Okay. Well, this is equal to 0, right? So if this is m squared plus 1 squared equals 0, we can just focus on m squared plus 1 is equal to 0. And then we just got to remember that this part here, it's squared. Okay, so meaning whatever m is, we'll do it again. And if that does not make sense, it'll become clear in a second. So if we solve for m, this is equal to m negative 1 plus or minus square root. Right? Let's put on the other side and square rooted, which is equal to plus or minus I. So yeah, it looks like we don't have a real situation here. And I say real because we don't have a real number here. So this is usually in the case where we say this is alpha plus or minus beta I. And in this case, it's 0 plus or minus beta. No, not beta. Our beta is what? Our beta is technically 1. So it's 1i. Okay. And then what we should say here is that we have a multiplicity. So what multiplicity means is that, remember how I said earlier, we can just remember that this whole thing is squared here? Well, another way of saying is that we can remember that we have a multiplicity of 2. So right now we have plus or minus I, and then we'll have plus or minus I again. So I'm going to write all the roots, and we're going to have 5 roots, and you're going to see what that means in a second. Multiplicity. Okay, if I spelled that wrong, I don't care. 2. Yeah, I can't spell. That's what computer's done to me. They've took away my ability to spell. So we have m is equal to 0. That's up here. And I'll just write we have 0 plus or minus. Wait, let me say m is equal to I'm gonna stop writing the 0 here. Go to I. M is equal to negative I. M is equal to I. M is equal to negative I. So like I said, there we go. We have our 4 roots. And what I did, yes, I just took the positive version. I took the negative version because it's a plus or minus, right? So I go the positive version, the negative version, and then since I said we had a multiplicity of 2, I just repeat it again. So we have the exact same thing. Okay, now the formula for this case, where we don't have real numbers, so we write it as y is equal to e to the alpha, 1 second. Don't forget your constant, c1, e to the alpha x, cosine beta x, plus c2, e to the alpha x. Stop, don't do that. Don't underline. What am I underlining? Sine beta x. And as you can imagine, that for us would be y is equal to c1, which is 0, cosine, and what's beta, right? Beta is just 1. So we'll just write as cosine x and c2 e 0 sine x. Now I'm going to simplify this a little bit more because e to the 0 power is 1. We just say we have c1 cosine x, and we could say we have plus c2 sine x. Okay, so by the way, this is not the final answer because we had a multiplicity, right? And we also had this root. So what I should actually say here is we have y1 and y1. Well, we have y2, which is going to be x times y1. So if you have a multiplicity of something, to make up for that multiplicity, to make up for the duplication, you times this all by x. So that's if this was a duplication, and it is because look, I, negative I, and it duplicates, right? It's I, negative I here, so we times the whole thing by x. And if this was duplicated once again, we would actually do it as x squared y1. And that would be if we had a multiplicity of 3, but we only have a multiplicity of 2, so it's x times y1. So this would be x c1 cosine x plus c2 sine x. Okay. And why is my screen not loading? Hopefully that wasn't too long. My screen didn't load, but yeah, you guys heard me. This is all it is right here. Okay, but we have one more solution. We have y3, and that's this guy. Well, what is the most general form for y3? Well, the most general form for a situation with the real root is actually pretty easy. It's the most simple form. It's c1 alpha x. Why? I'm going to write it as mx. Okay. And what is m for this form? Because m is this is a real one. Real one. So this is a c1 e to the 0, which is equal to c1. By the way, let's not call it c1, because we used c1 before. We could call it, and we also called that c1, c2. I'm going to change the names of these real quick. I'm going to call this c5, 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 and I'm going to call this c3, c4. Okay, so then what we now do, we have our complementary solution. So this is your final answer. You say yc, and you can say this is the sum of y, I, so all these little y's together. And what would that be? So c1 is c1 cosine x plus c2 sine x plus all of that, which is x, c3 cosine x plus sine. Nope, don't forget your constant. The constant in front of it is actually pretty important. You will lose points if you don't include that. Sine x plus c5. And that is your final answer. Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.